Hi, everyone. Let's hope that this session goes smoother. Waiting for our speaker. Here he comes.
Hi, Annie.
Hi.
Okay.
We just had major difficulties in the last presentation, but
Saw that, yeah, because I tried to get on half an hour earlier and couldn't. So, but anyway, now I'm on, so that's the important thing.
yes.
And I see how to share my screen, and I'm talking, so I think this is working. And I have my presentation ready to go. I think I'm ready when you're ready. So what's going to happen?
Here comes Janie. Janie's going to be your moderator. I'm hoping that we can hear her because she couldn't get connected last session. And she'll introduce you, and she'll also monitor your questions. And if there's time permitting at the end, she'll be able to help you out there. And
I have to show my video. Do I have to do that?
You'll need to, yes. And
oh no, I need to. I know I have to do that for my presentation. Share my screen.
Yeah.
Should I do a picture of me though?
It's up to you.
Ann, can you hear me?
Okay.
Oh, Janie, we can hear you now. Thank goodness.
I have no idea what happened in that last. I didn't have a mute button or an unmute button. I looked at Zoom Advanced, said press your space bar. That didn't work. So I apologize.
I feel so bad for Tom because we lost like 15 minutes of his presentation.
Yeah. Good job.
No idea what happened. Technology can't always be counted on. I'm going to go ahead and mute myself and my video, and since you're on here, you can start at your discretion.
Okay, so I just want to point out, because I'm just going to push the little green button down here that says share screen and go into my PowerPoint and keep talking, correct?
Correct. Yep. All right.
Let me. I'm getting.
Maybe that's me. Let me turn off the conference then. Okay.
Let me try that. Nope.
You have your microphone on in both. Didn't we get warned by Ann that
yeah,
there could be feedback?
I did turn my microphone off. All right, let's go ahead and get started. Thank you. Bob, can you hear me?
I can hear you just fine, yep.
Okay. We're going to go ahead and get started. We thank everybody for joining us. We also want to thank our project sponsors, PADEP, the Environmental Digest, the RIPA, Earth Conservancy, Ernst Conservation Seeds, Graymont, and Tetra Tech. I'd like to introduce Bob Hedden, who's going to talk about 50 years of AMD pollution remediation at the Anna S mine. Take it over, Bob.
Okay, you can see my screen, correct?
Yes.
Okay. So Bob Hedden here. I'm going to talk about the Anna S mine, which is a site I've been working at, that we've been working at Hedden Environmental for 20 years. And any of you who know Hedden Environmental can see that the credits here are going all the way back to Kim Weaver, who was actually my first employee at Hedden Environmental, was the engineer who who managed this whole treatment system up here. So, so this is, of course, a project which has had many involved parties and supporters over the years. Here's some of the credits of who's involved here. But the site is, the ANS mine is located in the Pine Creek watershed. It actually is in the Babb, the Wilson Creek watershed, which flows into Babb Creek, which flows into Pine Creek in Blackwell, just at the end of the Pennsylvania Grand Canyon. This area has been mined for the Bloss and other coal seams. I mean, the Bloss seam. This is about the northernmost extent of coal mining activity in Tioga County and in the northern tier of Pennsylvania. And here's a USGS map. You can see the old spoil sites, and you can see where the ANS mine is. This is on the western side of State Route 287, which is going from Morris up to Wellsboro. And the mining there on the right there in the eastern side is associated with the town of Antrim, where there's a lot of mine drainage as well. So what makes this site interesting is there's been a whole lot of monitoring that's gone on up here over the years. And there's been a lot of mining, of course. You know, the area was deep mined in the late 1800s through to, the 1930s. And then it was surface mined in the 1970s and 1980s. And during that process, right before the surface mining, Operation Scarlift happened, which was very convenient since we had a good baseline of what was up there. Then there was monitoring during the daylighting and the surface mining by USGS. And then through the permitting activities, Antrim Mining did a lot of monitoring. And then in the middle 1990s, DEP came in and Beach Creek Watershed Association, and we got involved monitoring in order to design a passive treatment system that got installed, and then that's been monitored. So lots and lots of data. 2 discharges up here. Hunter's Drift, which is the drain out of the mine, has highly variable flow rates because it's a drain. When it rains a lot and water gets into the mine, a lot of water comes out. It gets to be very low flow rates during dry periods. These mines, the ANS mine is an above drainage, unflooded mine. And there's very little neutralizing capacity up here in the rock. And so you end up with pretty severe, very severe mine drainage, low pH, ferric iron and aluminum, that kind of water. You're going to see that. There are 2 entries that were used. So the drift is just to drain water. Then the main entry in the mine is called S1, the S1 entry. And we see bad water coming out of there. And the second entry was the S2 entry, but that got reclaimed, that got eliminated during the reclamation, during the remining period, but there still is some water coming out of there. There's the Hunter's Drift. Oh, we want to just stop that phone. There's the Hunter's Drift discharge. You can see that, anyway, that's a drain for the mine, and that's bad looking water. If you know mine drainage, that looks bad, it is bad. There's the Anna S1 discharge. That's where the miners went into. And you can see there also is water coming out of there. So this was the water quality measured during Operation Scarlift, which was, for those of you who don't know, that was a large inventory of mine drainage conditions that occurred in Pennsylvania in the middle 1970s. And it's a real good baseline for all the restoration projects that are going on now. Yet usually Operation Scarlift becomes, at least the 1970s source of data. Here you can see what the water quality was. Quality is sort of a bad word to use here. It's bad water, pH in the high 2s and low 3s, and you guys can read this. High concentrations of acidity, which is due to, which in Scarlift they didn't measure aluminum, but very high concentrations of aluminum in these discharges. We'll see that. And the iron, which is mainly ferric here. So poor water quality. So what are the daylighting in the 1970s and 1980s, the remining that occurred? It happened on the crop. So it happened near the discharge, the drift and the mine discharges. They took out some stumps from the old mine, and they also, there was apparently a seam above the Bloss seam, the Cushing seam, which couldn't be deep mined, but could be surface mined, and so they mined some of that. And so the area was mined, that they avoided the direct impacts to the two main discharges, Hunter's Drift and S1. And the site was reclaimed and actually is in good shape now. It's completely vegetated, and they did a very good job of regrading and vegetating the spoils. As I mentioned, the overburden is net acid, very little neutralizing capacity, and this remining, the surface mining occurred before there were acid-base accounting requirements or alkaline addition requirements, so there was no alkaline addition. So this is a good, shows you what happened to the water quality, and that this is the kind of the data I'm going to show you for a couple of the sites. You can see what we have here is the years on the x-axis in the acidity milligrams per liter, and this is the Hunter's Drift acidity. So what you can see is that before the daylighting starts, so that's Operation Scarlet, you can see the concentrations of acidity there ranging between about 250 and 500. Then the daylighting occurs, and obviously things get much worse. And then the daylighting ends and things start to settle back down to a condition which is actually not very dissimilar from what it was before they started. But you can get sort of the time frame there of how long that took and what that process is. This is for the S1 discharge. That's the entry that is also a major source of water. And you can see the same pattern here. But I think if we go back, yeah, see the scale here on acidity for Hunter's Drift, it goes up to 2,500 milligrams per liter acidity. The S1, the scale only goes up to 1,200. So things got worse, but not as bad. And you can see that over time, things have improved and are back to the original condition, or actually a little better than the original conditions in the 1970s. And this is S2, same pattern for S2. So this then table shows the pre-surface mining conditions and the conditions during and after the surface mining. And what you can see here with numbers is what we saw on the graph, that things got much worse. The acidity concentrations doubled. And now we have aluminum concentrations. We can see that there's very high concentrations of aluminum. This is really bad water. And the loadings, which are calculated, of course, from the flow and the acidity, the loadings, the S1 discharge actually didn't increase much because the flows went down. Mike Smith, who actually was involved in the post-permitting of this at the Moshannon District Mining Office, said, you know, this didn't surprise him, since part of the remining process is to get water out of the mine, and so to try to keep water from flowing into the deep mine. They apparently were successful here. But as you can see for the Hunter's Drift discharge, the acidity loading up there, that the kilograms per day doubled during this period. And that's not good. And so as a result of these changes in the chemistry coming out of this mine, and the same time this was happening, there was the same kind of mining going on across the valley in the town of Antrim, and same things were happening over there. So this increased acid mine drainage pollution severely polluted Wilson Creek, and then Wilson Creek runs into Babb Creek about a mile below where these discharges come in, and it devastated Babb Creek all the way down to Pine Creek, and Pine Creek became impacted downstream of Babb Creek, and got a lot of people's attention. In 1990, the Fish Commission came around. They did a survey, no fish in Babb Creek below Wilson Creek. And that prompted the Babb Creek Watershed Association to be formed, very active group that's had a lot of impact up in this watershed. Took a little while for the bureaucracy to catch up, but eventually Babb Creek made it onto the 303D list. Actually, Pine Creek, the section of Pine Creek below Babb Creek, was also put on the 303D list. And due to the activities of the DEP and the Babb Creek Watershed Association, Antrim Mining, who did the surface mining up here, they built a lime treatment plant for the discharges on the Antrim side of the valley, so the opposite side. But nothing was done for the discharges over here from the NS mine, and that's where the DEP, led but really by the Moshannon District Mining Office, really pushed the Growing Greener program the new Growing Greener program, to find a way to install passive treatment, if feasible, over here on these discharges. And that's where I got involved. My head environmental got involved. And these are the data that I've circled here. This is what we use to design the treatment systems. And so you can see things were already getting better, but they even have gotten, you're going to see here, they've gotten a little better yet again as time has gone on. But this is the kind of water that we then use. We had flows in chemistry, flows associated with all these data points, and we were able to do loadings and do the design of the passive treatment system. Now, note the concentration of acidity here, 500 milligrams per liter acidity. And actually, okay, this actually shows you those concentrations that we use for the design. So this is the pre-passive treatment system. And you guys can see what's going on here. We still have, water's a little better, but still very lousy. And a lot of ferric iron, a lot of aluminum, very severe water. And so how severe is this? Well, the OSM and DEP, BAMR, or just DEP, have developed what they call the risk analysis matrix that gets used for any watershed groups or conservation associations or anybody outside of the DEP who wants to receive funding to build a passive treatment system. You have to use this matrix to determine whether there's a low chance, a medium chance, or a high risk that the system will fail. And if you're in the low, you're probably good to go. If you're in the medium, you have to explain how you're gonna mitigate for failure of the system. And if you're in the high, you can just forget about it. And the guidance just says you need to install chemical treatment. Well, here's where we are with the Anna S and the Hunter's Drift discharges. So we're in the high, and in fact, for the Hunter's Drift, if there even was a super high, we were in the super high there. So very, very risky situation, which according to this guidance is not worth spending money on because it's the high risk of failure. So the matrix didn't exist in early 2000, in the late 1990s and early 2000. So we didn't have to deal with that. We just had to deal with our best professional judgment about how to treat the water. And this is the design matrix, that gets used commonly. And in this case, we have acid water. And we looked at this time, really the only choice for the acid water was a vertical flow pond approach. And so that's what we did. And in that kind of system, you have a vertical flow pond. You discharge into ponds and wetlands to polish the water coming out of the vertical flow pond, and that's your system. And this is what a vertical flow pond looks like. And so it's a pond that has a layer of, in this case, 3 feet of limestone aggregate at the bottom, covered with 1 foot of alkaline organic substrate that has standing water on top of it. And the system is flooded because of water level control structures that are installed. Water flows into the vertical flow pond on the surface, flows down through the organic substrate, and benefits from contact with all the microbes and the organic compounds in the substrate and the microbial activity going on there, and then flows down into the limestone substrate, which of course generates alkalinity, and then out. And so this is what one of the vertical flow ponds looks like. It's not very exciting. It's just a pond with some algae in it and some submerged plants. But there's actually a lot going on here. All the water there is eventually, to get out of there, has to go down through all those alkaline substrates and be treated along the way. And here's the wetlands that are up there. This is the wetlands associated with the Hunter's Drift system. We had lots of room we had enough room to build a nice wetland system for the Hunter's Drift system. We didn't have as much room for the NS system. We really only have a pond there to polish the water coming out of the vertical flow ponds. But as you can see, this is really, really nice wetland system up here. So here's what we built. The other thing we did here, which is very important, is we went out and actually did a soils and bedrock and groundwater investigation before we developed the design. And what we discovered was that we had a very hard sandstone bedrock up here that you could not work in. You can't go get through it. So, but what we found was there was associated with that sandstone, there was a bench sitting on top of it, and there was a bench below it. And so we ended up dividing up the treatment systems. We actually built 2 treatment systems, one on the upper bench and one on the lower bench. The upper bench received flow from the ANA S1 and the ANA S2 discharges. There were 4 vertical flow ponds. And what we did is we actually take the water over from, I'll just use ANS as an example. The ANS water comes into a flow distribution box, which then distributes the water into 4 pipes, which go to VFP 1, 2, 3, and 4. Each of those VFPs discharges to a ditch that carries water into the wetland, which then goes to the receiving stream. Same deal for the Hunter's Drift, except because the Hunter's Drift was collected at it's a drain, I think it was about 15 feet lower than the ANA S and ANA S2 discharges, and because of that, we couldn't get it into this upper bench, so we put it on a lower bench. And same deal, bring the water over, just split it up into 4 flows, send those flows individually to VFPs, 5, 6, 7, 8, discharge into, in this case, into a large pipe because we couldn't fit a ditch in here, but into a large pipe that then discharges into a series of wetlands and eventually discharges to the same stream that goes down to Wilson Creek. It's what it looks like from the air. So very cool place. Now the North Country Trail goes right through the treatment system. It's very accessible. You can get up here, and if you go for a walk on the North Country Trail in Tioga County, you should definitely make a point to go look at the treatment systems. So this is a big deal. This, at the time, was the largest Growing Greener project, and to take you back in history, Growing Greener started in, it was like December of 1999. I think the Ridge administration, they wanted to have the first grants done before the year 2000 for some reason. Maybe it's, I'm sure it was election year. And so there were grants were started to go out really in 2000. So this has been the second year of Growing Greener. And this was by far the largest grant to a watershed association awarded that year. And I probably, maybe since, I don't know of any grants that are this high. $2.5 million, with 2.2 million of that was Growing Greener. 300,000 of that was from Office of Surface Mining. A lot of stuff here to spend that much money. That we had to pipe the water to the treatment systems because those benches were not located right next to the sources. So we had to get the water to them. A lot of pipe, as you can see, a lot of materials. 39,000 tons of limestone. We bid that out separately in order to get the best price we could on that. And 6,500 cubic yards of spent mushroom compost and 4 acres of wetlands. So what's been the result of all that? This table shows the average inflow chemistry, the average chemistry out of the vertical flow ponds, and then the average chemistry at the final discharge. Because the vertical flow ponds generate alkalinity, as you can see here, but they don't remove all the iron. And so you need to have that polishing step to remove all the residual iron. And what you can see here is that, that the final discharge in both sites is alkaline, pH 7.5, strongly alkaline, negative acidity. That means that we're net alkaline. And iron concentrations that are low, and aluminum's is very low. And the manganese, which actually is not removed by the vertical flow ponds, which from a geochemical perspective makes sense. The manganese removal that does occur happens in those wetlands, and it mainly happens in warm weather conditions when there's a lot of growth going on in the wetlands. But we do get some manganese removal. I'll point out to the geochemists, the biogeochemists out there to look at the sulfate numbers out of the vertical flow ponds. You can see that there's actually very little removal of sulfate in these vertical flow ponds. That means that the acidity neutralization and all the alkalinity generation we're getting is coming from limestone dissolution. It's not to say that that organic substrate isn't very important in maintaining and protecting the limestone from armoring by iron. Very important, but this is really a limestone. The remediation here is very much dominated by limestone dissolution. Okay, so that's the average chemistry. What's it look like day to day? one of the things that is important for any mine drainage treatment system, whether it's active or passive, is if it's reliable treatment, if it provides treatment all the time. This is the net acidity of the final discharge at Hunter's Drift. So in this case, 0 means that it's a neutral discharge, and negative acidity means it's net alkaline. So I could have put this in positive numbers with net alkalinity, but this is a nice measure because it's easy to compare to acidity. So what you can see here, what we want is we always want negative numbers coming out of the system, because that means pH 7, net alkaline conditions, and you all can see that's what we got. Never have we had a bad water sample. I think from a pH perspective, the lowest pH we've seen coming out of this system is 6.5. Always have had good water for 15 years. ANS system, same thing. Same thing. Negative net acidities, pH 7.5 water. Never have we had a bad sample coming out of the ANS system. So how is this, this isn't without work, okay? These sites are actually well monitored, and they're maintained very diligently. And there really is, in my mind, there's 2 kinds of maintenance that gets done on these types of systems. One is the routine maintenance, which involves, regular inspections of the site and removal of, the kind of maintenance that you can do with a shovel, or even if you have to mobilize in a local piece of equipment to clean out a ditch or something, but easy stuff. And up here, they're fortunate, we have the Babb Creek Watershed Association. Babb Creek is a special place, but it's a good model for other places. There's a landfill up here. And when the Babb Creek Watershed Association was formed, it had some leadership that was adamant that they needed to get money, and they went to the landfill and they were able to negotiate a tipping fee. Part of the tipping fee at the landfill goes into actually the Babb Creek Trust, and that's used to pay to operate the Antrim lime treatment plant, and also to support the activities of the Babb Creek Watershed Association. There's one full-time employee, and I think there's about one half-time employee. They mainly run the treatment plant, but they also spend their time doing inspections of all the passive treatment systems up here, which there are about 8 of them. And when you take their budget and it's all audited, it's really nice numbers. It turns out that I was able to allocate about $10,000 in 2018 that went to their activities up there for routine maintenance. The other thing that has to happen up here is occasionally you have to do big stuff. And that's beyond the capabilities of the Babb Creek, beyond their technical capabilities and beyond their financial capabilities. So that requires raising outside funding and bringing in outside contractors. And the main thing up here is the replacement of that organic substrate. That organic substrate is key to maintaining the viability of that treatment system. And also then, while you're doing it, repairs to the collection systems and access road improvements, stuff that takes some money. Well, in order to figure out when that should be done, I've stayed involved up here. And here we are. One of the advantages of our design is that we're able to turn off one vertical flow pond system at a time. And so what we did is here's one of the vertical flow systems that's been turned off, and we dig holes, and this is a good result. When mine drainage flows through fertile organic substrate, it turns black. That black is indicative of good biological activity. And this is a good result. This is a bad result. There's no black in here. There's aluminum, there's iron. This substrate is exhausted and it needs to be replaced. And in fact, so that's what we've done up here now as well. We've cleaned out the substrate. Here's the process we've used. Here is the vertical flow pond where the old substrate is piled up in the middle and the new substrate is being placed around. And we've done this to all the vertical flow ponds up there. 2 grants from Growing Greener, $210,000 in 2012, $201,000 in 2016. All of the vertical flow ponds have been rebuilt. What's been the result of all this work? Well, the big result of this work is that we got good water quality, as you can see. And in 2010, Babb Creek was removed from the 303D list. parts of the stream are now designated as wild trout. Pine Creek also got removed from the 303D list. So that's good. And the last part I want to address is, okay, well, this worked, but it was really expensive. Was it worth it? And we can do that by looking at all the numbers. Got lots of numbers here, we know all the costs here. And what I did is I took all the costs and brought them all up to 2018 when for this presentation, which was really done last year. And it turns out the treatment system today would cost about $4 million for the construction and engineering. And so still would be awfully expensive treatment system. We know what the routine O&M is, and we know what these major maintenance activities are, but you only do those every 12 years. And so I took those numbers and I compared them to chemical treatment, because remember, with the guidance said that you can't treat this passively, you really should be installing lime treatment or chemical treatment. So I actually got from the DEP costs for doing for the Hollywood and the Brandy Camp treatment plants, which are operated by AMR, and the Orchid Schmale site, which is operated by the Knox District Mining Office. We got all kinds of numbers for that. The only thing missing is we don't know design costs, so I just guessed at 15% of construction. There's no major maintenance for those sites because we don't know how often they're going to have to rebuild clarifiers and rebuild equipment, but we know annual costs. And so when you take those numbers, you end up with an annual cost for 20 years of operation of each of these systems, which is $382,000 for ANS. That's all the construction, major maintenance, and minor maintenance, all thrown together and discounted over a 20-year period. And then you can see I've done those calculations for the chemical treatment sites. Well, you got to put this into some kind of perspective. And so the perspective is how much alkalinity does each system make? And that's easy to calculate from the flow rates and from the chemistry, which we know. So we know how many tons per year of alkalinity is generated by each system. So we do a little math, and the NS system is making alkalinity at a cost of $1,100 per ton. The Hollywood treatment plant is making alkalinity at a cost of $2,200 per ton. You can see the numbers. The lime systems are all very similar, around $2,000 to $2,500 per ton, about twice as expensive as the passive treatment. So the summary is Babb Creek's been hammered by acid mine drainage for over 100 years. It's been fixed. And the reason it's been fixed, in my mind, has to do with the treatment system was designed very conservatively and very carefully, and that was important because we've survived hurricanes. We've survived muskrats, and vandalism. We've survived lots of things up there. The chemistry of the water got better. Very important part of this story. This is true everywhere in Pennsylvania. The chemistry of the water, which was so bad in Pennsylvania in the 1970s and 80s and early 90s, is getting better, and that's helping us. And really important here is we have a Babb Creek Watershed Association, which has been very diligent and taking care of the system. And the good news is all the success has been achieved for half the cost of what it would have been to install a chemical treatment plant. Thank you. Oh, didn't leave much time. Sorry, Janie.
Oh, no, that's okay, Bob. There is a question here, but I think you probably answered it, but I'm going to ask it anyway. Considering you are high risk for state funding, what are the plans for OM&R funding into the future?
Well, I think I did answer that. The funding that was received to replace the organic substrates, that was from Growing Greener. That was from the O&M category that's in the Growing Greener program. So my thought is, in this case, Babb Creek takes care of the routine activities forever, anyway, in the near future, but the major stuff's gonna have to come from grants, hopefully Growing Greener or something like that.
All right. Excellent presentation, Bob. We appreciate it. For those of you that need professional development hours, please go to the Resource Center and fill the forms out. And anyone, please send comments on your review for the presentation. Thank you all very much for joining us.
One more thing, all this stuff was just published in a paper in the journal, the Mine, Water, and Environment Journal. And if anybody sends me an email or does it through the conference, if you're interested in getting a copy of that paper, get hold of me through the conference, I guess, and I will make sure you can get a copy of that paper.
Okay. Thank you, Bob. Thank you, everybody. Bye.